This video provides useful information on the process for preparing electric vehicle customers' single-family residences for safe and reliable electric drive vehicle charging. Specifically, it addresses safety, technical, and consumer issues electrical contractors and inspectors should be fully familiar with prior to the installation of electrical vehicle supply equipment, or EVSE, for charging electric vehicles. First, before diving into the details of EVSE, Pat Davis of the U.S. Department of Energy will address our nation's efforts to have 1 million electric drive vehicles on the road by 2015, including the importance of home charging.
Hello, I'm Pat Davis, Manager of the Vehicle Technologies Program of the U.S. Department of Energy. We are at an exciting time in the history of our nation's transportation system. Electric vehicles have entered the market and are now available. In late 2010, the Chevy Volt and Nissan Leaf were introduced in select locations, and in 2012 we will welcome the introduction of a number of additional EVs produced by major auto manufacturers. These vehicles will be offered in various configurations with different all-electric driving ranges, some completely all-electric, others will be plug-in hybrids. The automobile industry is clearly stepping up to the plate in the delivery of advanced electric drive vehicles suitable to broad segments of the consumer market. In his 2011 State of the Union address, President Obama stated his goal to have 1 million EVs on the road by 2015. Electric drive vehicles offer the potential to significantly reduce petroleum consumption and oil imports, while we reduce emissions and, contrary to popular perception, are highly responsive and fun to drive. The fuel cost to drive an EV is 1/3 or less that of a conventional gasoline vehicle, and electric drive vehicles can achieve overall life cycle cost savings compared to conventional vehicles. Now, EVs have been around for a long time, and in fact, in the early 1900s, accounted for more than half of the light-duty vehicle market. Then advances in internal combustion engine and increased availability of petroleum soon led to the dominance of gasoline-powered vehicles, which has continued to this day. Recognizing a few periods of interest in electric drive during the 1970s and early 1990s. So, the question is, what has changed? Why are things different now? There are several reasons. The first is that in recent years there have been major advances in energy storage technology. These advances have been most promising in lithium-based battery technology, which has led to significant improvements in energy and power density, along with reduced cost. There have also been steady achievements with regard to hybrid powertrain developments, power electronics, and electric machines. The second major thing that has changed is the urgency of our nation's energy and environmental challenges. And lastly, the corporate average fuel economy standards for 2016, along with the prospect for further corporate average fuel economy standard changes post-2016. A key component of the successful introduction of EVs is the deployment of charging infrastructure in parallel with these vehicle rollouts. The automotive industry strongly believes that home charging is essential, followed by an appropriate level of workplace and public charging as the market for EVs unfolds. Safety, followed by the overall consumer impression of the installation and charging experience, is of course extremely important. Electrical contractors and inspectors are critical to the successful market introduction of electric vehicles. The electrical contractor is responsible for the safe and cost-effective installation of EV charging equipment and is the principal coordinating entity between the consumer, equipment manufacturer, utility, and local authority having jurisdiction. More than anyone else, the electrical contractor is responsible for an overall positive consumer experience when installing EV charging equipment. The local inspector ensures that the installation has been wired safely and has been done in accordance with the latest code requirements. And most jurisdictions require that the installation be permitted and inspected. I would like to extend my appreciation to the electrical community and the vital role you play in the successful introduction of EVs across our nation. Thank you.
Next, Ted Bone of the Department of Energy's Argonne National Laboratory will provide an overview of electric vehicle supply equipment and charging options, including level 1, 2, and fast charging.
My name is Ted Bone. I'm with Argonne National Laboratory. We're here in the Electrified Powertrain Renewable Fuels Lab. We're going to use the vehicles and facilities in this lab space to describe charging installation and charging infrastructure. All electric vehicles, or plug-in electric vehicles, have a level 1 charger in the trunk of the vehicle, which has a level 1 AC connector on one side and a level 2 AC connector, the J1772, on the output side that is compatible with the connector on the vehicle. These are wall-mounted, such that there's 2 very large mounting screws or more to screw it to the wall. The cover needs to be removed to access the internals. Inside are the AC input block, where you can see the 2 AC mains and the earth ground, and the output wires are pre-wired. The Leviton unit has a different approach, that it uses a pre-installation base plate that's screwed to the wall, and it has dowel pins on the back that snap into the base plate. It also is pre-wired with a NEMA 6-20 240 volt 20 amp connector that normally has a lockable enclosure over the plug as another way to meet the National Electrical Code. Inside you can see there's no user terminals needed. It's a very simple, straightforward enclosure. The AeroVironment unit is also wall mounted, has convenience hooks on it to allow the electrician to hang the front panel down below as he makes the internal connections to the AC mains and the earth ground. The power feed can come in from the bottom or from the rear, depending on how things are mounted, and has a O-ring on the front to seal it. And as you can see, not much electronics inside for all the safety interlocks. These are non-intelligent charge stations, which do not have an RFID or other way of doing billing. So these are direct on-off. There's a lot of confusion about level 1, level 2, level 3 AC versus level 1, level 2, level 3 DC, and world harmonization of standards. We saw the level 2 connector for most charge stations in the United States. So most charge stations in the United States will use the SAE J1772 level 2 AC connector, which is up to 80 amps if you have an appropriately sized cable. This cable is sized for 30 amps. The connector has the basic 5 pins of the main power, the earth ground, the pilot wire, which governs the amount of current that the charger can draw, and the proximity pin, which is the interlock to make sure that the power is removed before the connector is extracted. In the United States, we use single-phase power for both level 1 and level 2. And of course, level 3 AC is 480 volts. So level 1 is 120, level 2 is 240, level 3 AC is 480 volts. If any of you are looking at Nissan vehicles, they use the Japanese Jari connector. And so this is JEVS G105 1993, which has 2 pins that are 150 amps and 8 interlock pins, so 10 total. This is going to be superseded by a combination of the DC and the AC to simplify the process. And that's how the world is harmonizing on AC standards and combined with DC standards. And this is level 2 DC. So what you'll see is level 2 home, level 2 public infrastructure, and then level 2 DC, which is up to 200 amps. Level 3 DC is 400 amps, and level 1 DC, which is unknown to most people, will also use this and use the communication pin to facilitate using the existing connector up to 32 kilowatt on this 42 millimeter connector. So in general, harmonization within the globe between the US, Europe, China, and Japan is ongoing. And in the United States, we've settled on the SAE J1772 level 2 connector for 240 volts, and the combination connector for level 2 DC and level 2 AC. Some confusion out there about the difference between charging stations and chargers and the thing that you are charging, which are batteries. So in all electric vehicles, there are electrochemical energy storage systems with a battery management system on top of each card that tells the charger, which is this unit or this unit, how much DC power to take from the AC lines and put into the battery. So this system of the charger and the battery management system govern the amount of electricity that goes into the batteries. For a 24 kilowatt hour vehicle charging at 3 kilowatt would be 6+ hours of charging. For smaller vehicles, it would be less, and of course for a plug-in hybrid vehicle, which might have a 4 to 6 to 8 kilowatt hour capacity, it would be in the 3 to 6 hour range. Inside the charger, there's sophisticated electronics to convert the AC power into DC power, along with the communication to the battery management system. These can be air-cooled or liquid-cooled. The measurement system of AC power is usually done off-board. Some units have a metering circuit inside of it. Some units have an external one that is owned by the utility. Much like the regular full-size meter, it has a sub-meter. Sub-metering is an important part of the smart grid and the way utilities can bill out energy that is distributed to the electric car separate from energy that is delivered to the rest of the residents or to the business.
Article 625 of the National Electric Code, NEC, sets forth installation safety requirements for typical hardwired connections of plug-in electric vehicle battery charging equipment. In particular, Article 625 covers the wiring methods, equipment construction, control and protection, and equipment locations for electric vehicle charging equipment. Throughout Article 625, the intent is to prevent users of electrical equipment associated with the vehicle charging system from being exposed to energized live parts and to provide for a safe vehicle charging environment. It's important to note that electrical contractors installing EVSE equipment for home recharging of electric drive vehicles install according to NEC Article 625.
But it all starts in chapters 1 through 4, your general requirements in the NEC. And the reason I say that is because in chapter 1, for example, you have your requirements that deal with listed equipment and installing listed equipment in accordance with its installation instructions. Chapter 2, you have your overcurrent protection requirements for branch circuits. You have your grounding and bonding requirements for installations. In Chapter 3, you have your conductor sizes in Article 310, and you have your wiring methods covered in Chapter 3. And all of those are inherent components for installing a branch circuit to service equipment or a panel board that's going to supply electric vehicle supply equipment. And then what you have in Article 625 is the specific requirements for that type of equipment.
Some of the key tenets of Article 625 include 625.5. All electrical materials, devices, fittings, and associated equipment are required to be listed or labeled. 625.13. Electric vehicle supply equipment rated at 125 volts, 15 or 20 amps, and listed as suitable for the purpose shall be permitted to be cord and plug connected. All other electric vehicle supply equipment shall be permanently connected and fastened in place. It's important to note that 240 volt, 40 to 80 amp EVSE can be cord and plug connected as long as the EVSE meets the requirements of 625.18, 625.19, and 625.29. 625.18. The EVSE shall provide an interlock that de-energizes the electric vehicle connector and its cable when the electrical connector is uncoupled from the electric vehicle. 625.19. The EVSE, or cable connector combination of the equipment, shall be provided with an automatic means to de-energize the cable conductors and electric vehicle connector upon exposure to strain that could result in either cable rupture or separation of the cable from the electric connector and exposure of live parts.
The level 1 and level 2 could be cord and plug connected. Level 1 typically is cord and plug connected, but level 2 you have the option, and it's all related to how the level 2 is listed and evaluated and identified for use. If it's listed and identified for use in a cord and plug connected application or arrangement, it would be suitable for use, and the authority having jurisdiction would verify that through the installation instructions and the nameplate information on that equipment.
625.21. Overcurrent protection for feeders and branch circuits supplying electric vehicle supply equipment shall be sized for continuous duty and shall have a rating of not less than 125% of the maximum load of the EVSE.
If you have a continuous duty load, which is inherent to EVSE, a continuous duty load being one that is in place or on for 3 hours or more, it's required not to exceed 80% of the branch circuit rating.
625.22. The EVSE shall have a system of protection against electric shock. Standard ground fault circuit interruption equipment, or GFCI, does not provide the range of protection needed for the various types of charging systems. 625.23. For electric vehicle supply equipment rated at more than 60 amps or more than 150 volts to ground, a disconnecting means shall be provided and installed in a readily accessible location. The NFPA NEC technical committees are currently working on clarifying NEC requirements for electric vehicle supply equipment, such as individual branch circuit requirements and equipment that is permitted to be cord and plug connected. This is to ensure that effective application of essential code and safety requirements can be applied to all EVSE installations. In addition, it's important to note that local conditions may require amendments to the National Electrical Code. Finally, the National Electrical Contractors Association has developed a National Electrical Installation Standard, NEIS, for installing and maintaining electric vehicle supply equipment. NEIS 413 addresses all safety concerns in addition to important performance and quality aspects of the installation.
The National Electrical Code is set up for adoption by any local jurisdiction, be it at the state level, municipality level, county level, town level, city level, and they usually will adopt the National Electrical Code into law, meaning that that's the law and one must do at least that much. Often in particular jurisdictions there may be conditions that may be unique to that area, such as high heat applications, problems with corrosion in the soil because it has a high alkalinity content. Those are specific things that are unique to that area that may cause a need for specific amendments to the National Electrical Code. But the National Electrical Code really is the minimum. Once adopted, one must do at least that much to ensure a safe and essentially safe electrical installation. NECA has developed a family of National Electrical Installation Standards that are ANSI accredited. They're ANSI approved standards. That means they are fully vetted through an open consensus balloting process through industry experts. So the NEIS, if you will, complement the NEC minimum safety requirements, and they provide quality and performance aspects in a manner that is easily understandable as to what constitutes good workmanship in electrical contracting, ultimately providing customers with the highest quality electrical product from the contractor.
Preparing a home for electric vehicle charging and metering requires the collaboration of several parties to help consumers make the right decisions for their individual needs. Automakers, auto dealers, electrical contractors, inspectors, utilities, consumers, and cities each play important roles in this process.
The number of players in the electric vehicle ecosystem is very broad, and it seems like it's getting larger all the time. But obviously, it's very important from the automakers are a very critical key to this process. What type of charging equipment is needed? What's coming standard? As customers look at developing or installing a charging station in their home, the automotive dealer may be involved in the process. Many automakers are looking at third-party installers to manage the process, and that could be somebody from the automaker, could be maybe a third party from a utility standpoint, somebody who's managing the installation process. Obviously, you have the infrastructure supplier itself. Where's the equipment coming from? Who's the manufacturer? The electricians, the inspectors, the permitting process, the utility from a rate plan standpoint, and the communications, the customer service requirements. So there are many actors in the play of getting an electric vehicle charging equipment installed correctly. And there needs to be a lot of communication among all those players to ensure the customer is not confused in the process.
What's important for the electrical contractor is they become the conduit to all these different parties, the conduit to the utility contractor, the conduit to the county and getting the permit, etc. So they're going to get the information out to make sure that everybody's on board and what we're doing is okay. It's not causing any problems, no red flags or whatever. And that's what's the process, probably the key to the whole process, is to make sure that this communication takes place.
Once a consumer has made the decision to purchase a plug-in hybrid or full battery electric vehicle, the first step is for the consumer to contact their local utility to discuss rate plan options.
As utilities are looking at different programs to offer for electric vehicle owners, that may include different rates, like time of use rates, or different off-peak pricing, but that also could translate into what we call demand response programs, which historically have been done more for air conditioners or electric water heaters. In that situation, at peak times, we're able to send a signal, and if the customer has agreed to participate in a program, we can interrupt those loads for a specific agreed-upon period of time.
The type of vehicle purchased, consumer driving patterns, and the local utility rate plans will determine the most advantageous EVSE strategy for the homeowner.
So, for example, if you were to buy a plug-in hybrid car that has 10 to 20 to 30 mile all-electric range, it will recharge in 4 to 6 hours on a 110, 120, 15 amp service. So it might be sufficient. Go home, use that service, plug in, not be concerned. If you go to a 40-mile range, like the Volt, you may decide that you want to have a little bit faster charge. So you charge in 2 to 3 hours. So maybe you would still use level 1 if you wanted to, but you could go to a level 2.
The utility may dispatch a service planner to evaluate the adequacy of the local transformer and service drops and evaluate the consumer's electrical plan. In any case, failure to notify the local utility can result in possible delays, service interruptions, and costly transformer upgrades. At this point, the consumer selects a licensed and bonded electrical contractor. The electrical contractor assigns a licensed or certified electrician to assess the consumer's home wiring and panel needs, keeping the customer's rate plan and charging level preferences in mind. The electrical contractor will evaluate the home in regards to the EVSE load impact on the existing service capacity. He'll calculate the current and intended electrical loads to determine what modifications, if any, need to be incorporated in the EVSE installation. Based upon his evaluation, the electrical contractor will recommend one or more installation scenarios to the customer for consideration. A variety of potential scenarios exist with regards to home charging EVSE installations.
If you have a home that has air conditioning, it has a swimming pool and a spa and microwaves, you may have a panel that's even a 200 amp panel that could be completely full, and you may have to change that panel and upgrade that. Or you may have like my home in Manhattan Beach, where I don't have air conditioning and I don't have electrical appliances. I have a 100 amp panel, and I had plenty of capacity when I installed my infrastructure for my Volt. Depending upon those two scenarios, you and your electrician will talk about what you need to do to upgrade that panel, and the electrician will be able to do a load calculation for you, be able to evaluate what the cost will be, and give you guidance.
The simplest and cheapest scenario would be where the consumer has decided to measure home and electric vehicle loads together under existing rates. In this case, it is likely that no meter replacement is required, and the electrician will be able to use the existing panel, either as is or upgraded. Remember, if the EVSE exceeds 80% of the branch circuit rating, an individual branch circuit is required. A second scenario is when a time of use approach has been selected by the customer where home and vehicle loads are measured together, but rates are higher during the day and lower at night. In this case, the meter may need to be replaced, but the existing panel can still be used either as is or upgraded. A third scenario is when the electric vehicle load is measured separately from the home load. The home load would remain on the current rate and meter, while the electric vehicle load would be tracked through a separate meter, with a rate higher during the day and lower at night. This two-meter approach requires that a second panel or meter socket box be installed. A fourth scenario is one where the local utility supports installation of a sub-meter, which is tapped into the existing panel and can track electrical vehicle load separately from the home load. Similar to the installation of a second meter, a sub-meter permits data processing of electric vehicle charging profiles, which can be useful in examining the effect of price on the consumer's home charging behavior. Once the consumer has selected the appropriate rate plan, charging option, and metering, and electrical panel and wiring approach, the electrical contractor initiates the permitting process. In general, the permitting requirements for EVSE Level 2 home charging installations are treated as a standard residential electrical repair upgrade. Typically, a single-line diagram of the EVSE installation, load calculations, and site plan are sufficient for pulling a permit, although requirements vary by jurisdiction.
The process is generally very expeditious, especially if the contractor arrives with the critical information, the load calculations, where it's being installed, the wiring methods, and arrives with proper licensure and certification. The process can move very quickly in almost all cases if those conditions are adhered to.
The U.S. Department of Energy has developed a model permit for residential home EVSE installations. The model lists the applicable codes and installation requirements in one document for easy reference by the contractor and the local approval authority. The model permit is not meant to replace or supersede the forms and procedures already in place locally. The model permit can be downloaded from the U.S. Department of Energy's Clean Cities website. Upon permit approval, the electrical contractor will arrange for the installation of EVSE in the approved location as indicated on the permit. The electrician should follow appropriate safety protocols, including wearing personal protective equipment or PPE, and adhering to lockout-tagout procedures.
Concern you have is when you're having to work with an electric panel that's energized. In new installations, obviously, you're not energized yet until we actually get a final inspection and the meter gets installed. But when you go into retrofit, at some point, we are now running our material back to the panel, and we have to now take the panel cover off, enter that panel when it's energized. And if we don't have an existing breaker outside that we can turn it off and de-energize it, then there's no choice but to work it energized, at which point we have to use our PPE, personal protection equipment.
The electrician will install service upgrades, panel upgrades, wiring installations, and all other requirements as listed on the approved permit. It's important to note that future metering requirements are not fully established and may vary from state to state. For example, the protocols for EVSE metering systems and other options for sub-metering are just now beginning to be addressed by the California Public Utility Commission. Upon completion of the installation, the electrician will call for an inspection as required by the local building code. If meter work is required, the local utility will be contacted for meter installation after the approved inspection.
The electrical inspector is your best protection. A certified and trained electrical inspector will make sure that the home is wired safely and that the installation of the electrical vehicle charging system is done according to the latest code requirements, both state and nationally. When the inspector arrives on the site, the first thing he or she will look for is the location of the pertinent equipment, and will make the determination that things are located where they are allowed to be, of course, and then look and make sure the job is complete, that the equipment is installed properly, that the equipment installed carries the proper listing marks, and that the proper wiring methods have been used. At this point, the inspector will ask the installer to remove the panel covers after locking out and tagging out and adhering to all the proper safety provisions, wearing any personal protective equipment that may be required during that process. So we want to ensure that safety throughout that whole process. Then the inspector will examine the equipment, look at the diagrams and the calculations, make sure everything is in compliance, and if all is found in order, they will give it a green tag and release the job.
The electrician will provide orientation and instruction to the customer regarding the EVSE equipment installation and ensure that all relevant manuals, documentation, and warranty information are handed to the customer. Wrap up and best practices. Be sure to encourage the customer to contact the local utility before the initial assessment to ensure the customer understands rate plans and hardware implications. Be conversant with the utility's electric vehicle rate plans and installation implications to guide the customer through the process. Confirm that the customer's plan is approved by the local utility planner as necessary prior to starting work. Provide the customer with estimates for 1 and 2 meter options as applicable to prevent delays and added costs if the customer changes rate plans. Be familiar with the local utility's electric service requirements to preclude locating panels in areas that are not compliant. Offer the customer options, such as a second service line to a second panel in some instances. Stay current with the local utility on electric vehicle charging and rate updates. Anticipate playing a coordinating role among the customer, the utility, and the local authority having jurisdiction. Participate in the utility planner's visit to the customer site, in person or by phone, to discuss the electrical plan as necessary. Understand the types of EVSE, which type is to be installed, and establish communication with the EVSE manufacturer as needed. GFCI protection is required for 125-volt, 15 and 20-amp receptacles installed at dwelling garages and outdoor locations. Many EVSE have internal GFCI protection. Check your local code for proper installation guidance. Be very familiar with all NEC and local installation requirements. The EVSE is considered an appliance with a continuous electrical load. Consumers will need good leave-behind material to let them know who to call if they have problems. Remember, the electrical contractor is the conduit of information among all parties and must be sure adequate communication takes place. There are a number of resources available to assist electrical contractors and inspectors with regards to installation of EVSE for home charging, as well as provide broader electric vehicle-related information. To find out information and installation guidance on EVSE, a primary resource and starting place is the EVSE manufacturers themselves. For training and fundamentals of electrical installation practices, local apprenticeship programs are an excellent resource. As the National Electrical Code is cyclical, being updated every 3 years, license renewal is often tied to a continuing education requirement. Local licensing entities are often another good source of information on proper installation of EVSE. Nationally, there are a number of excellent resources, including the National Fire Protection Association, or NFPA, which maintains the National Electrical Code, the National Electrical Contractors Association, or NECA, the Electric Vehicle Infrastructure Training Program, EVITP, the International Association of Electrical Inspectors, IAEI, the Society of Automotive Engineers International, SAE International, and certified testing laboratories such as Underwriter Laboratories, CSA International, and others. Finally, the U.S. Department of Energy's Clean Cities program is an excellent resource for comprehensive information on electric vehicles and electric vehicle supply equipment. Thank you for watching this video on the process for preparing electric vehicle customers' single-family residences for safe and reliable electric drive vehicle charging.